Each part of today's lab is going to involve some measurements involving a series of resistors. And for each of the sections, you're going to start off by making sure you measure each of the resistors that you're interested in measuring. So you're going to want to set your meter to one of the resistance scales that's appropriate for the size of the resistor you think that you're measuring. So for instance, for the 1 kilo ohm resistor, I'll set it on the 2 kilo ohm scale, and I'll measure it by, so you can see it here, putting the lead of the meter on each of the wires of the resistor, and then it should show the value. So make sure you do that for each of the resistors, because they're not going to be exactly what they're rated as. This one is supposed to be 1,000 ohms, or 1 kilo ohm, and it's 0.987 kilo ohms. So make sure you do that for each of them. Then the first portion of the lab involves wiring the resistors in series. There's a number of ways you can wire resistors in series on the proto board. I'll show you one of them. One way actually is I could do this. I could put one resistor here, so it's crossing the threshold. And then I can put this lead of the next resistor next to the first one, and then bring it to another row, such as this. So I'll do like that. It's the 10 kilo ohm one I just wired in there. So you can see right here, there's one lead goes from here to one resistor has one lead in this hole here. The other one, it crosses the threshold, is in another hole here, and then the next resistor is in the next hole, but its other lead is in a different row completely. So it's not physically shorting out, which is how we want it to be. And then I can wire my third resistor in like this and have it go to another row over here. This is just one of many ways that you can wire resistors in series. There's a lot of wrong ways you can wire them in series. You don't want to have both leads of the resistor in the same row, for instance. So be careful of that. But right here, you can see that I have the third resistor, its lead is in the same row as this one, so they're connected electrically. Then it crosses over the threshold, and its lead goes into here. Okay, so let me fix that, make sure its lead actually does go into a hole. That one didn't. If they don't go into a hole, you won't get any measurement, which isn't good. All right. Then I'll wire my batteries in. Again, you did this part. I suggest putting the positive one on the left side, the negative one on the right side, and then putting a jumper wire such that this side of this first resistor is, before I actually wire it to the battery, I'll pull the battery out. I'm supposed to measure the resistance of this whole combination. So I put one lead of the meter here, the other lead of the meter there, and if everything's connected, I should see something. Oh, I need to change the scale. If you see a 1, maybe make the scale a little bit higher so that you can actually see what value it is when you put them in series. When I put them in series, I get 11.7 kilo ohms in this case. Okay, so that's the process for wiring it in series. And then to connect it to the battery, I will go back to this. I put one jumper wire here, another, and it's connected to the positive side of the battery, which I need to make sure stays in that hole. Okay, so this wire is right in that hole right there, and that hole is electrically connected to this hole that the battery is coming into. So there's like a wire from here to here, which then goes to this resistor through this wire, and so this resistor is then connected to the battery. The other end of the resistor goes to that one, and vice versa, all the way down to here. Then I have to connect this hole all the way to the negative side. That way I will have all of my resistors in series. I can use an orange wire. I'd rather have a black wire, but I don't have many black wires. But now my series resistances are all set up, and I can change my meter to measure voltage. And I can measure the voltage across each of the resistors. That was 0.5 volts. This one is about, let me change the sign here, 5.28 volts, 0.53 volts. Should add up to about 6 volts, because that's the voltage of my battery right here. Okay, so that's 3 resistors in series. I want to show you 3 resistors in parallel, and you do something very similar once you have them in parallel. And there's, just like with series, there's a number of ways you can wire resistors in parallel. Here's one of them. If I put these 3 resistors in the same, and have their leads in the proper holes, you're supposed to still start off with the values that are asked in the lab. I think for the parallel case, I want one of each. I want a 1,000 ohm resistor, and a 10,000 ohm resistor, and a 470 kilo ohm resistor. So you're going to take those 3, and you're going to wire them. You could wire them this way. There's more than one way to wire resistors in parallel, but this is one of the ways you can do it. Where, once I get it wired, I'll be able to show you more clearly. There we go. It's a little hard to get it into that hole. There we go. I think it's in. That one's in. That one's in. And I'll put this one in. Actually, those two are the same. I'm going to use a different value. I'm going to use this one on the left is 1,000 ohms. This one in the middle is 470,000 ohms, 470 kilo ohms. It's much bigger value, although the resistor looks the same size, but it's not the size that causes the value. The value is written on the resistor using those little bands. And then I have my 10,000 ohm resistor, which is right here. Really like it to be in the hole. I notice these leads can start to bend, such that they bend and they don't actually penetrate the hole. You want the tip of the lead to be deep enough down into the hole that it'll actually make an electrical connection with the proto board. So I'm going to show you what this looks like. I'll adjust the angle a little bit so you can see it more clearly. The 3 resistors have their lead, all of their leads, in these 3 holes because they're all electrically connected to one another. And these 3 leads are all electrically connected to one another. So these 3 resistors are all in parallel. And I can then measure them if you want. I can take a wire and put it on one side. Let's see, here we go. There's one side there. And the other side, there we go. And I can take my meter and hook it up here, and I should get a reading that is the value of my parallel resistances. Oh, sorry, it's on the voltage setting. I need to turn it back to the resistance setting on the meter. And I have it on 200 kilo ohms, and it's probably going to be a really small value. Yeah, it says 0.8 kilo ohms, so I can actually drop this to maybe the 2 kilo ohm scale will give me a much more accurate reading. There we go, 0.894 kilo ohms, so it's less than 1 kilo ohm. Okay, so that's how I would measure the resistance when they're in parallel. And then, of course, I can wire them up to the battery as I did earlier, and then measure their voltages across each resistor. If I get the wire in this hole here, there we go. Then I can wire up my battery, and I'll show you that this is indeed wired up so that the resistors are all in parallel. Okay, so now my battery's wired up. So I'll show you the way things are right now. Whoop, that wire just popped out. Put it back in. So here's my battery, my 6-volt battery. The plus side goes into this bus right here, and it's connected to that red wire, which then feeds into this side of the parallel resistors. On the other side, I have my negative side of the battery right here, which is electrically connected to this orange wire, which goes to the other set of resistors there. So then if I want to measure the resistor voltages, I change this to the voltage setting. I'm setting it on 20 volts. And then I put my meter across each of the resistors, and then I can measure what the voltage is across each of them. I'll let you do that. You know what they should be, probably. Check to see if that's what they are. Finally, there's a combination series parallel circuit, which I think you're using the same 3 resistors for, if I recall. I'm just going to check that. And I can even use part of this arrangement here, but I draw a little schematic for you, and the 2 resistors that you want in parallel for this case, I'm sorry, it's a combination of 2 in series, and those 2 in series are in parallel with the third one. So I'm going to take the 10 kilo ohm, which is this one, and I want that in series with a 1 kilo ohm. So I'm going to take the 10 kilo ohm and I'll put it in here like that. I'm going to take the 1 kilo ohm, and I'll show you what I'm doing in just a minute. I'm going to put that in series with the 10 kilo ohm. Again, this is just one way to wire it. Okay, so let me just show you. This is part of the one part of the circuit. This branch here, this is the 10 kilo ohm resistor. So one of its leads is in this hole right here, right there. The other lead crosses the chasm, like the moat. So it's electrically not the same hole as that one, which is good. That's how we want it. There's not going to be a short circuit there. But then this lead from the 1 kilo ohm resistor is electrically connected to the 10 kilo ohm resistor. It's like there's a wire there. Then the 1 kilo ohm resistor's other lead is in this row right here. So the last thing I need to do is I need to put the 470 kilo ohm resistor in there along with these other 2. I want it to be in parallel with the series arrangement of these 2. So here's the magic part. I'll put one end of the resistor in a hole that's in the same row as the 10 kilo ohm resistor. I'll put the other end of the resistor in a hole that's in the same row as the 1 kilo ohm resistor. So I have this one here, and I have that one there. And I just have to make sure I'm measuring them from the right spot. So I'll take the positive side, and I'll put it right here. The wire doesn't want to go in that hole because the wire's a little bent. So if that's the case, I'll try to straighten the wire with my finger like that, because you can see the wire's getting a little bit bent there. But this will make it more easy to enter the hole. There we go. And I'll put it into the what's called the positive bus, the battery terminal there. Well, I'm going to be measuring the resistance in a second, so I won't do that yet. And then on the other side here, I'll put this darker wire, which I'll plug into the negative side on the other end. Okay, so I can measure the resistance of this combination by putting one lead of the meter here and the other lead of the meter here, and seeing what the meter. Oh, I have to change it to the resistance setting. Let's see what happens when I do that. That's giving me a pretty small value, about 10.4 kilo ohms. So I can adjust the scale down to here and measure it. Actually more like 10.52 kilo ohms when it's on the proper scale. I always want to make it be the highest scale it can be. If the scale's too low, it'll exceed what it can do. If the scale's too high, it won't give you the same number of the same accuracy that you'd get otherwise. But the circuit here, as you can tell, is this series combination of these 2 resistors, the 10 kilo ohm and the 1 kilo ohm. These are in series right here. And this 470 kilo ohm is in parallel with a series combination of these 2. and then I put one wire here and one wire here, because it's the terminals that determine what's in parallel or series with what. Where I measure it is really important. It's going to be different if I measured it from a different set of terminals, like between those two. It's going to be different than if I measure it here. Okay, so where I put these wires makes it such that it's the 470 kilo ohm resistor in parallel with this series combination of the 10 kilo ohm and the 1 kilo ohm resistor. Then I'll put these little jumper wires into the proper hole so that they'll be connected to the battery once I connect the battery. So I go just like I did in the other case. Go there and there. So here's this jumper wire goes to the negative side. This jumper wire goes to the positive side. Then I plug in my battery. So the negative side of the battery, I put in the blue on the right. The positive side of the battery, I put on the red on the left. There's my full circuit. And the only thing I need to do now is to set this to a voltage setting and measure the voltage across each of the resistors. And I'm hoping that you'll predict it first and then measure it. So the one across the 470 kilo ohm resistor, I'm seeing over 6 volts. But that voltage is going to be split between the other two, between the 10 kilo ohm and the 1 kilo ohm resistors. If you get a negative reading on the voltage, just swap the leads of your meter, and then you'll get a positive reading. Okay, so those are the 3 sections. The 4th section, you're going to be designing your own resistor using combinations of parallel and series resistances from your kit. It asks you to come up and try to get a 16 kilo ohm resistor. So see what you can do with that, and then measure it. And then there's some comparisons between your measurements and your predicted values for each of your resistances. Okay, good luck with this, and have fun and learn a lot. Take care.